Dear students, today we're going to start transformations. In this topic we're going to cover 4 different types of transformations, which are the following. Number 1, reflections. Number 2, rotations. Number 3, enlargements. And number 4, translations. In this topic we're going to see how to have a shape and transform it using those 4 different types of transformations. There are more transformations, but those are in our syllabus. Let's start from the first transformation, which is reflections. So, we have 6 types of reflections. Mainly, we can reflect a shape. Number 1, with the x-axis. Number 2, with the y-axis. Number 3, with the line y equals x. Number 4, with the line y equals minus x. Number 5, with the line y equals a, where a is a number, an integer. And number 6, with the line y equals minus a. Sorry, x equals a. X equals a, where a is also a number. Now, to do these types of transformations, the first four are the ones which mostly come out in exams. There is a rule for each one of them. What we're going to see now, I'm going to start doing a transformation with a simple shape, and we're going to try to discover what is the rule which governs that transformation. So, let's start with a problem. So, plot the triangle ABC having points A 2,1, B 5,1, and C 5,3. Now I'm going to reflect triangle ABC. Number 1 in the x-axis. Number 2 in the line in the y-axis. Number 3 in the line y equals x. Number 4 in the line y equals minus x. The x-axis is sometimes called the line y equals 0. The y-axis is sometimes called the line x equals 0. Right? After doing those transformations, we're going to label the image P. We're going to label this image Q. We're going to label this image R, and we are going to label the image S. So let's start with that. Now, transformations are done on squared paper, so you will need a square paper for this part. I'm going to show you a square paper, how a square paper is. So I have my square paper. I'm going to draw the axis. this is 1, 2, 3, 4, 5, 6, and 7. 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, we have the 0, minus 1, minus 2, minus 3, minus 5, minus 6, minus 7. So I have the x-axis and the y-axis. Right? So let's start by drawing the shape. The shape has coordinates a2, 1, so that's a, b 5, 1, so that's b, and c 5, 3, so this is c. So there I have triangle ABC. That's our original shape. Now, the first transformation, we had to reflect triangle ABC in the x-axis. So reflecting in the x-axis, our mirror line is the x-axis. This is the line of symmetry because reflections are all about symmetry. This is the line of symmetry. So reflecting this shape by this line, we're going to end on the other side of the axis. So if B is 1 square up, it's going to become 1 square down. If A is 1 square up, it's going to be 1 square down. If C is 3 squares up, it's going to be 3 squares down. So I have my new point A, my new point B, my new point C. So that's my reflection. And we need to label that as triangle P. So I had the first reflection. Let's see what's happening. Let's see what's happening. A was the coordinate 2, 1. That coordinate became 2 minus 1. B was 5, 1 became 5 minus 1. And C became 5 minus 3 from 5, 3. So what do we notice here? As we can see, it's obvious that the x-coordinate didn't change, but the y-coordinate changed its sign from positive to negative. So our first rule. So reflection in the x-axis, if I have a reflection in the x-axis, I need to change the sign of the y coordinate, meaning that point x, y becomes the point x, minus y. And that is our first rule for the first reflection. Now, the second reflection, we had to reflect the shape, our triangle ABC, with the y-axis. So reflecting that with the y-axis, we're going to get the following. Point A is 2 squares from the y-axis. If the y-axis is our line of symmetry, point A will be 2 squares on the other side. Point B, which is 5 on this side, will be 5 on the other side. Point B, we're reflecting with this line, the y-axis. So point C, which is 5 from the y-axis, is going to be 5 from the y-axis on the other side. What do we notice? A now is the coordinate minus 2, 1. B is the coordinate minus 5, 1. And C is the coordinate minus 5, 3. Let's draw the triangle. This is Q. This is Q. As we can see, the y-coordinate this time, the y-coordinates didn't change. It was 1, it remained 1, 3 remained 3, 5 remained 5. But the x-coordinates changed their sign. From 2 it became minus 2, from 5 it became minus 5. So we can say that the rule to reflect the shape with the y-axis, we need to change the sign this time of the x-coordinate. So let's write it down. So a reflection in the y-axis means that we need to change the sign of the x coordinates, meaning that the point x comma y becomes the point minus x comma y. And that is our second reflection. Now we need to reflect the shape triangle ABC in the line y equals x. Mela, let's first see which is the line y equals x. Mela, the line y equals x passes from the origin, has a gradient of 1, meaning it passes from the point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on and so forth. So let's draw that line. I'm going to draw that line dotted. So this is the line y equals x. This is the line y equals x. And we're going to reflect the triangle ABC, the yellow triangle, with the line y equals x. Now, our line of symmetry is the line y equals x, so we need to see how far away is the triangle or the coordinates of the triangle from that line. Now, what can we see? I can see that A is half the diagonal of a square on this side, so it will be half on the other side. C is one whole diagonal on this side, so it will be one whole diagonal on the other side. B is two whole diagonals, so it's going to be two whole diagonals on the other side. So I have A, I have C, and I have B. Let's write the coordinates of these. So A is now the point 1, 2, B is the point 1, 5, and C is the coordinate 3, 5. Let's draw the triangle. Let's see what's going to happen. So this is triangle R. Let's see what happened. A, which was 2, 1, became 1, 2. B, which was 5, 1, became 1, 5. C, which was 5, 3, became 3, 5. So what do we notice? It's clearly that the coordinates are swapped. That which was x became y, and that which was y became x. Meaning that if we swap coordinates, it's the same thing as reflecting a shape in the line y equals x. And that is our rule. So let's write it down. So our reflection is in the line y equals x. We just need to swap coordinates. X becomes y, y becomes x. Meaning that the point x, y becomes the point y, x. Becomes the point y, x. So that's a very important rule, very easy rule. It's much easier to use the rule than actually counting up diagonals because it might be confusing. Our last transformation in this case is in the line y equals minus x. This also has a rule. Let's see it. Let's see first what is the line y equals minus x, and then let's see the rule. So the line y equals minus x. The line y equals minus x passes through the origin also, and passes, it has a gradient of -1, so it passes from -1, 1, -2, 2, -3, 3, and so on and so forth. I'm going to draw the line. This is the line y equals minus x. Now it becomes much more difficult because we need to count the diagonals. So A, our line of symmetry is the line y equals minus x. A is here. It's 1.5 diagonals, so half and 1, meaning this is my new point A. B is 1, 2, 3 diagonals away, so it's 1, 2, 3 diagonals away. That's B. Let's count C now. C is 1, 2, 3, 4 diagonals away, So it's 1, 2, 3, 4 diagonals on the other side. So now I have my new triangle. Let's see its coordinates. So it's -1, comma -2, A. B is the coordinate -1, -5. And C is the coordinate -3, -5. Let's draw the triangle. So now we have our triangle. That is our triangle. Okay, so that's PQRS. It's shape S. Let's see what happened. So the coordinate to 1 became -1, -2. The coordinate 5, 1 became -1, -5. The coordinate 5, 3 became -3, -5. As we can see, two things happened. First of all, the coordinates were swept from to 1 to 1, 2, and also the signs were changed. So reflecting a shape in the line y equals -x, we need to do two things. We need to swap coordinates and change all signs. Let's write it down. So a reflection in the line y equals -x means I need to swap coordinates first. Important, the order is very important. Swap coordinates, then change all signs. What does this imply? This implies that the point x, y becomes the point x, y are swapped, so yx, signs are changed, so -y, -x. So these are the rules for the 4 basic transformations, for the 4 basic reflections. Reflection in the x-axis, reflection in the y-axis, reflection in the line y equals x, and reflection in the line y equals -x. And there you have the drawing, alright? There's the drawing for that transformation. Now I'm going to show you how to reflect a shape with a line, with a vertical or horizontal line, which is not the x or y axis. Now in this case, we need to count squares, because there is no rule for a number which is always changing. So let's see an example. I'll draw quadrilateral this time. A, B, C, D, in which A is the point 3, 1, B is the point 5, 1, and C is the point 5, 4, D is the point 5, 3, 6. Then we need to reflect A, B, C, D first in the line x equals -1, and then we're going to reflect it in the line y equals 2. So those are our two lines in which we're going to reflect the shape. So I'm going to start by drawing the shape. Usual square grid. Draw the axis. Those are our axes. I have 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6. And just to inform you that each square represents 1 unit. You can't have different scales on different axes in this case. And it's very important that you remember that I can give you, or the examiner can give you, transformation, just square grids without any numbers. Just remember that 1 square is equal to 1. So let's plot A, let me remember, 3, 1, 5, 1, 5, 1, 5 comma 3, sorry, 4, 5 comma 4, and 3 comma 6. So that is our quadrilateral. I'm going to draw the quadrilateral. That's our quadrilateral. We're going to reflect that quadrilateral. First, transformation. We have to reflect it in the line x equals minus 1. So let's do that. So the line x equals minus 1. X equals minus 1 meaning the x-axis. The x-axis passes through minus 1 on the x-axis, and it is a perfectly vertical line. So let's draw the line first. So this is our line, the line x equals minus 1. The line x equals minus 1. So now, by counting squares, we can find the mirror image of the shape. So counting squares, it means from the line 1, 2, 3, 4 from A. So A is 4 on the other side, 1, 2, 3, 4. This is my new A. B is 1, 2, 3, 4, 5, 6 on the other side. So B is 6 on the other side. C is 6 up here, so it's 6 on the other side. D is 1, 2, 3, 4 from the line, so it's 1, 2, 3, 4 from the line on the other side. So I have A, B, C, and D, and that is our first reflection in the line x equals minus 1. The other reflection had to be done in the line y equals 2. So let's draw the line y equals 2 first. This is the line y equals 2. The line y equals 2, which passes through 2 on the y-axis, it is parallel to the x-axis. Alright, all the coordinates on this line have a value of 2 as a y-coordinate. So doing the same as we have done before, A is just 1 square below the line, so my new A is going to be 1 square up on the line. B was 1 square down, so B is going to be 1 square up. C was 2 squares up from the line, so C is going to be 2 squares down from the line, so that is C. While D was 4 squares up, so D is going to be 4 squares down. And there I have my new point D. So that's my new shape. I'm going to draw the shape. I have A, B, C, and D. And as we see, A, B, C, D ABCD is that shape, all right? It's been superimposed on the other one. It's not a problem, okay? Even though it's superimposed, we should still work, okay? So that's our transformation. You've seen it being done. I suggest you copy it on your squared paper copybook. So those are reflections. I'm going to write it down. One problem which you need to do at home after seeing this video. So draw quadrilateral A, B, C, D having coordinates A minus 2, 2, B minus 5, 2, C minus 5, 4, and D minus 2, 5. Reflect A, B, C, D. 1 in the line y equals x, 2 in the line y equals minus x, 3 in the y-axis, 4 in the line x equals 1. I suggest you plot coordinates, plot axis from minus 8 to 8 on both axes. So that's some work. I'll be giving you more work in due time. Thanks for your attention. See you in our next lesson. Our next lesson, which will be on rotations.